This video lesson is about subtracting integers. So first of all, the key idea, the most important idea, is that subtraction is the inverse operation of addition. Therefore, I can change subtraction to addition by adding the opposite. By inverse, we mean opposite. Subtraction undoes addition. And we'll give some examples of that in a minute. It's important to know that the additive inverse, or the opposites, look like this. So I have a 6 and a -6. These are numbers that are equal distance from 0 on opposite ends of the number line. Or 5 and -5. I can use a fraction, -4/3 and +4/3. So in addition, the sum of opposites, or the sum of additive inverses, is always 0. That's how I know they're opposites. So -6 and 6 is 0. These are also called zero pairs. Now I'd like to give a couple sample problems, so some examples. I'm going to start with an easy one. So I have the subtraction problem 7 minus 3. If I were to model that, it would look like this. Here's 1, 2, 3, 4, 5, 6, 7. I need to take away or remove 3. So I remove those 3. What I have left is 4. Now I can change this into an addition problem. And I do it by keeping my first number always the same, 7. And then I'm going to change my subtraction sign to addition, but I'm going to change this number to its opposite. The opposite of +3 is -3. Now I could model this. It would look like this. 1, 2, 3, 4, 5, 6, 7. And I would model -3, 1, 2, 3. I could see there are 3 zero pairs, so I would remove those. And my answer is +4. I could also use the rule to solve this problem. I have 7 plus -3. Now my rule is that I have different signs. I have a positive and a negative, so I'm going to find a difference. That means I'm going to subtract. And my answer will get the sign of the greater absolute value. 7 has a greater absolute value than does -3. So I know it's going to be a positive answer. I find my difference, and I get 4. I can do another problem. How about 7 minus -2? So I can model this. This would be 7. And I want to remove -2, but I don't see any -2. So to get -2 to remove, I'm going to add 0. So here's 1 0, here's another 0. A +1 and a -1 is 0, so I'm not changing the value of this. But at this point now, I can remove -2. Here they are. I take them away, and my answer is whatever remains, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can't use the integer rules for subtraction. It only applies to addition. So if I want to use my integer rule, I need to change this problem to an addition problem. So I have 7. I'm going to change my subtraction to addition, and I'm going to add the opposite of this value, which is -2. The opposite would be +2. I could model that. 1, 2, 3, 4, 5, 6, 7, +2, 1, 2. What do I have? I have +9, which is, you'll notice, the same answer. I could use my I could use my addition rule, which is same signs, they're both positive. So I add them, same sign in the answer. I'm going to give 2 more examples. So first example, -8 minus 2. I can model this. Here's negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I need to remove positive 2. I don't have positive 2. That means I need to add 0 to it. So I'm going to add that. There's 0. There's another 0. So I can now remove positive 2. Here they are. Take them away. My answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're negatives. So my answer is negative 10. I can also model this using addition. So I start with negative 8. And then I change my subtraction sign to addition, and I add the opposite of 2, which is negative 2. So I could model that, negative 1, 2, 3, 4, 5, 6, 7, 8, plus another negative 2, 1, 2, that equals negative 10. I could also use my integer rule for addition, which is same signs, same sign in the answer, and I add 8 plus 2, 10. I'm going to give one more example. I might take negative 8 minus negative 4. So I could model that with negative 8, 1, 2, 3, 4, 5, 6, 7, 8 negatives. And I need to remove 4 negatives. So 1, 2, 3, 4. I take away negative 4. And I have 1, 2, 3, negative 4 remaining. So this equals negative 4. I can show that with addition. I have negative 8. My subtraction sign changes to addition. I take the opposite of negative 4, which is positive 4. I could model this, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and add positive 4, 1, 2, 3, 4. I have 4 zero pairs. That leaves me with negative 4, which is the same answer. I could also think about the rule here. I have different signs. I want to find a difference. And my answer will take the sign of the greater absolute value, which is this one. So my answer will have a negative. 8 minus 4 is 4. And I get negative 4 using my rule also. So that is how we subtract integers. I hope that's been helpful to you.